Assalamualaikum. This is my tutorial video of our experiment. Um, Experimental test report 3 registry circuits to superposition case on taking theorem. So this experiment consists of two different portions of this experiment. The first experiment is based on the superposition principle. In the one, we'll just do this experiment in our room. So I'm now focusing on how to design this interface in multi-sig. Okay, let's get back to the software. So first we'll try to design this circuit here. So this is our software interface, and first we'll try to use voltage source here. So this is my voltage source. Just try to keep. So make sure that we'll just select the master database to select the components of the circuit. And we'll just use sources, compatible sources. So first we'll try to select this DC power as voltage source. So here it is. So my circuit is like that, 10 volts. Voltage should be rated with 10 volt. Uh, okay, now this is our resistances. So the main resistances are rated with 1 kilo ohm, 220 ohm, 100 ohm, 1.5 kilo ohm, and 320 ohm. So I'll try to um, take the resistances there. So first we'll take 1 kilo ohm resistor. Next we'll take 2.2 ohm resistor. This is my ohm resistor. Uh, the last one is 5 kilo ohm. This is 1.5 kilo ohm resistor. And the last one is 320 ohm resistor again. Okay. So let's get back to the sources. So this is our software interface. So we'll in this experiment we'll just focus on try to use place source and place basic. These are the two options we are going to deal with here. So let's switch our block. Taking out the limits. So we just it is a 5 volt voltage source, and this is a 10 volt voltage source. Now we try to design the circuit. Try to randomize the circuit same as like in the estimator report. Okay, to connect all the sources, connect all the elements of the circuit here. Uh, So this experiment has three different tables. So the first one is based on the measurements due to voltage one only. And the second one is V2 only, and the third one is V1 and V2, taking both of the voltage sockets. The first one, in this case, we'll take for first voltage source, and we will short circuited the second voltage sources as short circuited. So what we should do here in this case, we'll just limit these 5 volt sources here, simply, and make it as a short circuit in these cases. So what are the measurements we need? We need the measurements for the voltage source. The voltage is here. the load voltage. There you have considered the 220 ohm as our load here in this circuit. So we just take this is my the multimeter with this multimeter in our circuit. So this is my multimeter. We just try to work with it by clicking on right hand button. Just rotate it 90 degrees upwards. Okay. Now we'll try to connect the multimeter here across the load. Okay. So what are we going to measure here? We are going to measure the load voltages and the load power in milliwatt times. We'll just create it because load voltages. So after creating this circuit for the table, we'll just try to run this model. So we'll click the run button there. And afterwards, you see that this is our voltage drop across the load. And in order to measure the power here, so we'll try to stop this simulation. And we'll take a wattmeter here. This is my wattmeter. What we just do, you can also take these as wattmeter, and there is another option is the load power. We can also take these options. So this is another option to measure the power. So we are not so but for our learning purposes, we will take this wattmeter and calculate the voltages and calculate the overall power of this circuit. So what we just do is connect this source, connect these ports of the wattmeter there. We'll just remove this one, and we'll measure the current. So if we run the circuit, we'll measure both the voltages and the power of this circuit across the load. So if we press this run button here, so we'll see this is our voltage drop and this is our of the load power across the load resistance of this circuit. So this is for the first part. So if we go to the second part of the circuit, what we just do now we'll consider the second voltage source and we'll make it the short circuit now. So after removing it, we'll just try to connect this voltage source to this circuit. And our second voltage source is 5 volt here. So it has 5 volt. So this is my second circuit with my superposition principle. So now we try to measure the load power and voltages across this. We can see in consideration of the 5 voltage. If we run this circuit again, we'll see the voltage drop of the circuit is 1.342 and there is the load power of the circuit. Okay. So if we go to the last part of this experiment, so in this case, we consider both of the sources V1 and V2 in this case. So what can we do? We take both voltage sources into consideration in the circuit. So just cancel it down again. So we'll take this voltage source again here. So we'll take it as 10 volt. So if we consider this both of the sources, now we have the circuit to calculate the voltages and the voltage drop in power of this load resistance across for this circuit. So we'll try to click on the run button here and we'll just see that this is my power of the circuit, low power of the circuit, and this is my voltage drop. So in this way, we will try to feel we'll try to measure all these load voltages on the low power of the circuit, like considering three different scenarios of this superposition principle theory. So this goes for the part one of the superposition principle. We will go back to the second part of the simulation circuit. So what we will do, we try to measure the Thevenin voltage of the circuit and the short circuit current and the RTS of this Thevenin resistance of the circuit, as well as the how to calculate the maximum power using the maximum power transfer theorem of this circuit. This is my maximum. This is the we'll implement the formula of the maximum power transfer theorem in this scheme as well. So what we do here in this case, we will try to um, measure the Thevenin resistance here first. If you consider the circuit, let's try to copy it down. Okay. And first we'll try to remove all the voltage sources in the circuit. We'll also remove it down. No need for that. Of course, not. Okay. Sorry. Now we'll use a um, multi multimeter here. We're trying to rotate it down. Yeah, in this case, we'll try to flip horizontally, and we'll try to measure the Thevenin resistance of the circuit. So what we will do, we'll just try to connect the circuit with the multimeter here. We'll try to measure the Thevenin resistance of the circuit. So if you just click the run button here, we'll obtain the Thevenin resistances. So if we click it down, so 1 kilo, down, 1.5, okay. So this is my Thevenin resistance. So let's say we just apply this ohm button here. It will measure the Thevenin resistance of the circuit. After calculating the Thevenin resistance, we'll try to pause it down again. So we'll calculate the Thevenin voltages by using the superposition theorem in both of the cases. So what we will do in this case, we just remove it again and try to consider the circuit again in this case. So if we consider the first voltage sources, calculate the Thevenin resistance, we'll use the voltage source again. Yeah. So this would be considered as 10 volt here. In my circuit. In order to calculate the Thevenin voltage of the circuit, we need to remove the load resistance across this circuit here. So the thing is that we'll have to remove these load resistance outside 220 ohm to calculate the Thevenin voltage of the circuit. So in our first test, by applying the superposition theorem, we'll consider the first voltage sources here and also remove these load resistances here. So we'll take a multimeter here again, put it down, and we'll measure the voltage drop. We'll measure the voltage drop of the circuit. So if we run this file again, we can calculate the Thevenin voltage for the voltage source one. So this is my voltage drop. This is the Thevenin voltage one in terms of the 10 volt voltage source, first voltage source. This is for the first voltage source. And we are short circuiting the Second, voltage source of the circuit applying superposition theorem with Thevenin circuit. So if it posit on again. In the same way, we'll also calculate the mm, we'll also calculate the Thevenin voltage by removing this voltage source, this short circuit line again. We'll take the voltage source again here in this case. This is my 5-volt circuit. It will be the 5-volt circuit in this case. Yes. Just take it as 5-volt, connect it again. And this we'll connect the circuit again here in this case. So if we run this button, if we put the run button again for this, we considering the second voltage source in our circuit. So we'll calculate the Thevenin voltage, second Thevenin voltages of the circuit. After calculating two different Thevenin voltages, we'll minimize the second Thevenin voltage with the first one to obtain the overall Thevenin voltages of the circuit. So we put the run button now again. So this is my second Thevenin voltage of the circuit that I have found here for 5-volt voltage source. Okay, this is so after completing this and after completing we'll try to fill this form after calculating the Thevenin voltage of the circuit as well as the RTH of the circuit. So we have to measure the cross circuit current of this circuit. So what do we do in this case? We'll try to measure the short circuit current here. Um, okay, where's the circuit in this case? So what we'll just do, this is my circuit here. Well, now we'll try to measure the short circuit current. So, okay, this is my circuit. So what will you do to calculate the short circuit of this short circuit current of this circuit? We'll just remove the load resistance. We'll calculate the current here. So if you put the number of there, we'll just calculate the short circuit current. So we'll just use the multimeter here. Just make a little press. So we'll get the short circuit current of this circuit. So So what we are to measure the Thevenin voltage of the picture in amperes. So maximum to calculate the maximum power theorem, we'll use the we'll use the formula of the maximum power transfer theorem of the circuit that is just to be like let me write it down. So like equation will be like VTS the VTS squared by 4 into RTS. So this is my equation for the equation for the maximum power theorem of the maximum power theorem of the circuit. Then we calculate the maximum power. What is the first maximum power of the circuit that can be obtained from the circuit. So thank you. This is my tutorial for this module. If you guys have any questions, so we will discuss it in the for implementing the circuit in the lab section. Thank you. Assalamu alaikum.